There are three light rays, red, green, blue, incident on a right-angled isosceles prism PQR. The refractive indices are given as 1.27 for red, 1.42 for green, 1.49 for blue. We are supposed to trace the path of light rays through the prism, giving reasons. There is a concept of total internal reflection. When light travels from denser to rarer, if the angle of incidence is greater than critical angle, complete light will be reflected back to the denser medium by obeying the laws of reflection. That's only from denser to rarer. Rarer to denser, light ray undergo refraction bending towards normal. There is no total internal reflection. Whether rarer to denser or denser to rarer, both cases, the light is incident along the normal. Angle of incidence is 0. There is no refraction, light ray will go straight. So there should be a clarity. Total internal reflection takes place only when light travels from denser to rarer with angle of incidence greater than critical angle. If light is traveling from rarer to denser, there is no chance for total internal reflection. In this particular case, the light is first entering from air to glass, rarer to denser. The angle of incidence is 0. So all the three light rays supposed to go straight. So before that, we just discussed the general case, three cases, what happens when light travels from denser to rarer for total internal reflection and no total internal reflection cases. Like if the light is traveling from denser to rarer medium, if the angle of incidence is equal to critical angle, if you take sine on both sides, sin I equal to sin C. Sin C is 1 by n. If you are replacing sin C as 1 by n, sin I is equal to 1 by n. You take the reciprocal, 1 by sin I is equal to n. That means if I equal to C, angle of incidence equal to critical angle, 1 by sine of the angle of incidence will be equal to the refractive index. That time the light ray move along the surface of separation. If it's PR, the light ray will go along the surface of separation. If I is greater than C, sin I will be greater than sin C. Sin C you replace 1 by n, sin I will be greater than 1 by n. You take the reciprocal, greater than become less than. 1 by sin I will be less than n. So I greater than C, sin I greater than sin C. Sin I greater than 1 by n, sin C is replaced 1 by n. You take reciprocal, the inequality will change the sign. 1 by sin I is less than n. In this particular case, if I is greater than C, light ray undergo total internal reflection with angle of incidence equal to the angle of refraction. The third case, if I is less than C, sin I will be less than sin C, sin I will be less than 1 by n, when you take reciprocal, 1 by sin I will be greater than n. In that particular case, light just go refracting from denser to rarer, bending away from the normal. In denser to rarer or rarer to denser, both case, if angle of incidence is 0, the light goes straight without any refraction. This is only applicable to light traveling from denser to rarer medium. Now at PQ, all the three light rays, blue, green, red, have angle of incidence 0. So angle of refraction also will be 0. So all the light ray goes straight without any refraction till PR. Now at PR, the light is trying to go from denser to rarer medium, glass to air. So out of these three cases, one will happen because your I is not 0 anyway. We have to check whether I equal to C or I is greater than C or I is less than C, or indirectly whether 1 by sin I equal to n or 1 by sin I less than n or 1 by sin I greater than n. So I is needed. So draw the normal. Once you draw the normal, this is 45, this is 90, so this is also 90, this is 45, this is 90, this angle also will be 45, this is normal, so this angle is again 45. So the angle of incidence on PR is 45. So sin I will be 1 by root 2. 1 by sin I will be root 2, which is 1.414. So 1 by sin I is root 2, which is 1.414. Now you can check refractive index of each color with this particular value. So for red color, red is refractive index 1.27. 1.27, 1 by sin I, which is 1.414. 1.414 is greater than the refractive index of the result. So n is less. 1.27 is n. 1 by sin is 1.414. 1.414 is greater than 1.27, means 1 by sin is greater than n. That means I is less than c. So the light ray undergo diffraction and bending away from the normal. Now for green and blue both, the refractive index values are 1.2 and 1.49. 1 by sin I, angle of incidence is common for all the three, 45 degree, they are parallel. So 1 by sin I is also common for all of them, 1.414. 1.42 and 1.49 both are greater than 1.414. So the refractive index value is greater. Refractive index is greater than 1 by sin I. That means I is greater than c. The light ray undergo total internal reflection with angle of incidence equal to angle of reflection, not refraction, reflection. So this is 45, another 45, total 90 degree. They undergo reflection with incidence 45, reflection 45, so total 90 degree. The light ray will come straight. Both the light rays come straight down 90 degree with respect to the incident light ray. On reaching QR, this light ray is coming straight, they are coming along the normal. The angle of incidence is 0. So both green and blue on reaching QR will go straight without any refraction because the angle of incidence is 0 with QR.